Most SAT students hit the low to mid 700s on the math section and then completely plateau. No matter how much they practice, the score doesn't move at all. The real reason is the hard questions in the second module. In this video, I pulled up 5 of the toughest SAT math questions that are very likely to show up at the end of the second module. It's a collection of the most frequently repeated hard questions. I helped one of my students, Sarah, train with it as part of our strategy to recognize second module patterns faster, and she scored a 1520. And before I jump into this video, if the SAT is something you're actively working on, you probably want to subscribe to my YouTube channel, because everything I post is focused on helping you score higher without wasting time. Let's get into question number 1. Now, the first question says, the expression 6x to the fourth power plus 17x squared plus 7 can be written as 3x squared plus a times 2x squared plus b, where a and b are positive integers, or as 3x squared plus c times 2x squared plus d, where c and d are positive non-integers. What is the value of a plus c? Well, usually when I have a question like this, sometimes I have no idea where to start, right? When that happens, I like to do the easiest steps first, the steps that I know how to do, right? So when I look at this problem, well, I see 3x squared plus a times 2x squared plus b. I feel like I want to FOIL those, I want to multiply it out and see what happens, right? That's like the first thing that comes to mind. So that's what I want to do. So I'm going to multiply this times that. So that'll give me 6x to the fourth power. And then I'll multiply the second term. And that'll give me 3x squared times b. And then a times, so it's going to give me 2x squared times a. And then this times that. That'll give me a times b. So now, after I do this, you can kind of see that this expression looks like what's been given, right? So just by doing, I wasn't able to see this by just like reading the question. And when you read the question, you start to panic. You're like, okay, what am I supposed to do? Well, just do what you can do. I mean, it sounds basic, but most of the time, by just doing what's in front of you, the next step becomes a bit more clear, right? So now you see that you have like 6 to the fourth power plus 3x squared times b plus 2x squared times a plus ab. And if you compare to what was given, you can see that there are some similarities here, right? So you have the x to the fourth term, right? You have the x to the second power term, right? There are 2 of them, right? And then you have a constant. So first, what's kind of like the most obvious step here, right? Perhaps some of you are wondering, like, it's not obvious to me. But like I said, here there are 2 x squared terms, and here there's only 1. So let me combine those, right? So that we have 1 x squared term instead of 2. So we pull out the x squared, and I'll be left with 3b plus 2a plus ab. Right? So now it's a bit more clear. We can see here that 6 corresponds to the 6 that we already have. We have the extra term, and then 3b plus 2a corresponds to 17, and then ab corresponds to 7. So then we're just going to translate this into a mathematical expression. So 3b plus 2a corresponds to 17, and then we have a times b equals 7. Okay, so we have our system of equations here, right? So there are a couple of ways to solve a system of equation, but to save time, especially when you're doing the SAT and you want to go faster, you can use Desmos to solve this. However, if you were to plug in, 3b plus 2a, right, equals 17, well, because it's like, okay, Desmos wants like, x, y's, and if you use a and b, it treats it like a constant. So, or rather like a parameter. So what you want to do is, you could say that b is y and a is x, just to use decimals, right? So we could say 3y and 2x, right? And then our second equation would be, right, x times y equals 7. And here you have to remember, what does that mean to solve a system of equation? You need to find where those two functions, those two equations intersect, right? And for this example, right, it's going to be here and here. Notice that we have two values, right? Or rather, like four values here, right? So, and if you read the question, it says A and B are positive integers, and then C and D are positive non-integers, right? So here, when we're looking here, like 1.5 is not an integer, right? So we can already see that and 4.6, 6 isn't also not an integer, right? So we can see that this second pair represent C and D, right? So we can say that C equals 1.5, and then D equals 4.66667, right? And then we can we have here 7 and 1. Those represent A and B, right? Because those are integers, right? So A would be X, right? It would be our X value. So the X value here is 7, right? So A is 7, and then B would be 1. So now it's asking us to find what is the value of A plus C, right? So then we're going to do A plus C, right? So A plus C would give us 8.5, right? So that's the first question. Let me know if you were able to solve this, if this was too easy for you. Would you have gotten this correctly if you were solving this on the SAT, right? And which part would have given you the most trouble? So let's go ahead and solve the second problem. Okay, now let's take a look at the second problem. Well, it says if a function f of n equals 7 times 20.44 to the power of n over 4, gives each term of a sequence as the function of the term's position n in the sequence, where n is a whole number. The value of the term in the position 14 is p% more than the value of the term in position 10. What is the value of p? Right, that is a mouthful, right? And again, by reading it, it's like my first intuition is to do what's the most kind of obvious to me, right? Like the thing that I can do, like what I can do. I'm not trying to get to the answer immediately, but I'm trying to do what I can, and then hope that the next step would be a little bit more clear, right? So when I look at this, every time you have, you know, like a setup like this, sequences or f of n, and then they give you, right? They give you the position 14 because the n is the nth position, right? So they give you for position 14 and position 10. Well, I'll plug those in, right? I'll plug those in and see what happens, right? I'm not planning on solving the problem yet, right? I just want to make it a bit more digestible. Think of it as perhaps kind of chopping the the problem into pieces, smaller pieces, so that it's like a bit more digestible. For when you do that, it helps you also understand the question better, right? So I'm gonna go ahead and do f of 14, right? That would be 7 times 20.44 to the power of 14 over 4, right? And then f of 10 would give me 7 times 20.44 over 10 over 4. So I'm gonna use decimals for that, right? So this gives me 7 times 20.44 to the power of 14 over 4, okay? And I have this second expression, right? That gives me 7 times 20.44 to the power of 10 over 4. So they're saying that the value of the term in position 14 is p% more than the value of the term in position 10. Okay, so when you have, say, for example, if I were to ask you, if you had 1 and 4, how much percent increase do you need to go from 1 to 4, right? So usually when you have a question like this in a very, it's like, it's a bit you have nasty numbers like this, 270,000 to 259, right? It's like you want to perhaps reduce it into something something a bit more manageable, right? So instead of dealing with this big problem with like sequences or series or whatever, right? You want to turn it into something that's going to be easier for you to see if, your intuition makes sense. So let's think of this, right? To go from 1 to 4, right? What percent increase is that, right? For that, what you need to do is 4 minus 1 over your initial value times 100, right? So in this case, it's going to be a 300% increase. So if you're going from 1 to 4, it is a 300% increase, right? Perhaps that's not very clear. Maybe let's do, if you want to go from 1 to 1.5, right? This would be 1.5 minus 1 over your initial value, which is 1, right? So this then at times 100, then this would give you 0.5 times 100, then that's 50, right? So that's like a 50% increase, right? So then it's going to be the same concept here, right? So they're asking the value of the term in position 14 is more than the value of the term in position 10, right? And then they're asking by how much percent, right? So what we're going to do then is we're going to take this value, right, minus this, and then we're going to divide by our initial value, which was going to be the 13,222, and then multiply by 100, right? So minus that, right? And then, and be careful with, parentheses. Make sure that you have them in the correct order so that way you don't make mistakes. Right? And then times 100, right? There you go. So then we compare with the choices that we have, right? So in this case, this would be our answer, C. Hopefully that makes sense. If this wasn't clear, feel free to ask your questions in the chat, and I'll read the chat and, I'll get back to you as soon as I can. But yeah, let's move on to question 2. Okay, let's take a look at problem 3, right? So we're given a function. It says f of x equals negative 2x squared plus bx plus c. It says in the given quadratic function, a and c are constant. The graph of y equals f of x is a parabola that has a vertex at the point hk, where h and k are constant. If k is less than 0 and f of negative 5 equals f of 7, which of the following must be true? Okay, so basically I'm going to sound like a broken record, but, I'm going to start with what I know, right? So what do we know, right? We know that the vertex is going to be at negative b over 2n, right? And they're telling me to basically do f of negative 5 and f of 7, right? So it might not lead me to the answer, but that's the most obvious thing for me to do right now. So f of negative 5, right, would be negative 2 times negative 5 squared plus, right, so I have b times negative 5 plus c. Right, so then this would give you negative 2 times 25 minus 5b plus c. Negative 50 minus 5b plus c. And then we'll go ahead and do f of 7. F of 7 would be negative 2 times 7 squared plus b times 7 plus c. I'm going to rearrange. This gives me negative 98, and then plus 7b plus c. And then what else are they telling me? They're telling me that they're equal. F of negative 5 equals f of 7, right? So I'm going to set them equal to each other. So negative 50 plus 5b minus 5b plus c equals negative 98 plus 7b plus c. We can see here that the c's cancel out. So then I'm left with negative 50 plus 98 equals 7b plus 5b. Right, so then this gives me 48 equals 12b. Right, so then b equals 48 divided by 12, that's 4. So now we know that b is 4. So that allows us to basically already answer this one, because they're saying which of the following must be true. We know that this must be true, right? Because we just found out that b is 4, which is always better than 3. Right, so that is already true. So, but we still need to find out if C is strictly less than -1. So now we have B, and we have this vertex formula. So then we'll plug it in there, right? So then that will give us -4 over 2a, right? So that will give us -2 over a. Well, what is a? Right? So this is a in the quadratic formula, right? So this is a, the coefficient of x squared, right? And then b, and then c, right? So we know a is -2, right? So -2 over -2 equals 1. So our vertex is at 1. If you remember correctly, right, h and k are coordinates of our vertex, right? So h represents the x coordinates, and then k represents the y coordinates. We already have our x coordinates, which is 1. We need to find our y coordinates, which is k. Well, I mean, ultimately, we're trying to find if c is always less than -1, but we have another piece of information here that k is always less than 0. So how are we going to use that, right? We're going to do that by doing f of 1, right? Basically, when you do f of 1, f of x, right, that gives you y, right? When you plug in the x coordinates, it gives you the y coordinates, right? So by doing f of 1, right, we get -2, 1 squared plus b 1 plus c. We know that b is 4, right? And now they're telling us that k, right, which is the y coordinates, is less than 0. Right, so basically, they're telling us that this expression, a y coordinate, is less than 0, right? So then that tells us that this expression, right, is less than 0, because this is k, right? This is all k, and it's less than 0. Okay, so then we solve for c, right? So it's 0, and then 2 plus c, and then that gives us -2 and c, right? So this says that c is always less than -2, right? In the options they give us, it says c is always less than -2. It's always smaller than -2. Is always smaller than -1, right? And this one says that c is always smaller than -2, right? So that means that this is also correct, right? Because, if you have it in a number line, okay, so you have, let's take a look. So you have -1 here, and then -2 is here, right? So they're saying that C is always less than -1, so it's always here, right? And then this one says that C is always less than -2, so from here. So this is also correct. So yeah, because the answer says that C is a number that's less than -1, right? And in the answer we found, C is a number that's less than -2, right? So which is basically, so if you have it in a number line, right? So this one says that, okay, right? It says that C is a number somewhere here, right? And what we have here is that C is a number less than -1. So this is also correct, right? So then the correct choice is C, 1 and 2. Awesome job to those who've made it this far into the video. By the way, if you have a friend who is also planning on taking the SAT, well, and they're aiming for, say, a 1500 plus, be sure to send them this video. Perhaps they're struggling with, those tough questions on the SAT. Perhaps like they're still lingering around, 1400 or so, and they're missing those tough questions. This might be a great resource for them, So make sure to send them this video. That way they can, also take a look and see how I'm solving those problems. Maybe it might be helpful for them as well. Right. So let's get back into the video and continue with question 4. Question 4 says, right, the expression bx squared minus 13x plus 22 can be rewritten as h times x minus k times x plus j, where b is a constant and h, j, k are integer constants. Which of the following must be an integer? Right. So, and again, here we know the drill, right? So this is just begging me to do this, right, immediately. So, okay, that'll give me hx squared plus hx, let me do hjx, right, and then kx minus kj, right? So I did this times this and this times that. When we compare these two expressions, right, we can see that there are some similarities here, right? So we have an x term, and then a constant, right? And again, here we have two x terms. We want to combine those, right? So hx squared plus x hj minus k minus kj, right? What do we do next, right? So we know that h corresponds to this b, right? Because it's a coefficient of x squared, right? So then that gives me, we can say that h equals b. And then here, hj minus k, we can say that that equals 13. So that's the coefficient of the x term. And then we can say that negative kj equals 22. So now, contrary to the problem that we did before, I believe it was question 1 perhaps, here we have how many unknowns? 1, 2, 3, 4 unknowns, right? And we only have 3 equations, right? In order to solve a system of equation, you need the same number of unknowns as the number of equations, right? So if you have 4 unknowns, you need 4 equations, right? So since we have 4 unknowns and 3 equations, it's not possible to solve this, right? So now we're going to look at the options. We say, they're saying that which of the following must be an integer, right? The first option, we have k minus 13 over h, right? Well, when I'm looking at this expression, I mean, the only way to get that expression, it's probably going to come from here. Definitely not here, definitely not here. So probably here. So let's rearrange this equation. So here, if I k on the other side, right, I have h times j equals negative 13 plus k, right, which is basically the top expression, right? So I can replace this with hj, right? So negative 13 plus k equals hj. Negative 13 plus k equals hj over h, right? So then I can simplify the h, I can cancel out the h's, and then I'm left with j. So this expression is just basically the same as j, right? And we know that j is a constant because they told us, right? It says where b is a constant and h, j, and k are integer constants, right? So which of the following must be an integer? But we know that that first one is an integer. Like 13 is a constant, and we know that like b is also a constant integer, but we don't know what 13 over b would be, right? It's like you have 5, right? You have like 5 is an integer, and then if 3 is an integer, but like 5 over 3 is not an integer, right? But you could have like, say, 4 integer, 2 is an integer, and then 4 divided by 2, it gives you an integer. But in this case, we don't know, right? But they're saying that which of the following must be an integer, right? This option doesn't have to be an integer, right? It doesn't have to be an integer. Same for this one. 22 is an integer, but we don't know what j is, so we can't say for sure if the ratio would give us an integer. And same for this one, right? So the only one is this, where we know for sure it's going to be an integer. You have made it to the last question. Congratulations. Right, so in the comment section, to confuse the people who have not made it to this point, let's all comment a goat. Let's put a goat in the comment section. That way they're going to be so confused and what's going on, right? So let's start for our last question. So, well, this is a nasty expression, right? So it says 3x minus 7p times 5x squared plus 8x minus 4p, right, times 8 x cubed plus 3x squared minus 16x minus 48 equals 0. In the given equation, p is a positive constant. The products of the solutions to the equation is negative 560 over 9. What is the value of p? Right. So for this question, contrary to what we've been doing before, right? Because what was the point of what we were doing before, right? We would look at what's the easiest kind of step, right? What's the thing that just like the most obvious for us to do? Well, we don't want to do that here, because I don't know who would say that, multiplying this out would be very easy because this will be very nasty, right? So that won't be the first thing to do here, right? So, but they gave us a hint though, right? So here they're saying the product of the solutions. So every time, sometimes it's like the sum of the solutions, right? Every time you see these keywords, right, you want to remember the formula negative b over a, right, for the sum of the solutions, and c over a for the product of the solutions, right, for quadratic equations. But it's going to save you a lot of time, right? So if you're asking for the product of the solutions of a quadratic equation, here. If they're asking for the sum of the solutions, there you go. Okay. So another hint, or it's not so much of a hint, but every time you see, products like this, b, c equals 0, right? You can always do x plus a equals 0, x plus b equals 0, x plus c equals 0, right? So it's the same structure we had there. We can start with 3x minus 7p equals 0. Let's solve for x. But then x would be equal to 7p over 3. Okay, let's move on. This is our first solution. Let's move on to our second expression. 5x squared plus 8x minus 4p equals 0. Well, in this case, because it's quadratic equation, you can use this, right? So here I have two solutions here, right? The products of those solutions is going to give you c over a, right? So our c is negative 4p, our a is 5. Okay, so we have our second solution, right? So let's move on to the last expression. X cubed plus 3x squared minus 16x minus 48, right, equals 0, right? Here you don't want to do c over a because it's not a quadratic, it's a cubic, right? So you cannot use c over a, but you can use decimals. Okay, so we're going to plug this in. X cubed plus 3x squared minus 16x minus 48. Okay, and then we find the root. So every time you have a function and you're solving for x, basically you're trying to find the roots of that function, meaning where it crosses the x-axis, right? In this case, we have x equals negative 4, x equals negative 3, x equals 4. So now they're saying the products of the solutions to the equation is negative 560 over 9. What is the value of p? Okay, let's take the products of the solutions. Right, so 7p over 3 times negative 4p over 5 times negative 4 times negative 3 times 4. They're saying that this equals negative 560 over 9. Okay, this equals 7p over 3 times negative 4p 5. Okay, this, and again, if you're, not so comfortable with like doing like mental calculations, so you want to use your calculator, just to make sure. The last thing you want is like make a mistake on like silly things like 4 times 2 or something, right? So If you're unsure, decimals. 560 over 9. Okay, so now you have physically just like an equation with like one unknown, right? So you can use answers to solve this. And because you have a p there, again, don't use p, otherwise decimals will treat it like a parameter, right? So I'm saying don't use decimals. Obviously, I'm saying don't use p, and I go ahead and use p. So we can use x instead, right? So 7x over 3 times 4x over 5 times 48 equals negative 560 over 9. Okay? So, and you have your roots there, you have your solutions. The first being negative 0.83333. The second one, 0.83333. Okay? So the question says P is a positive constant. So we're not taking this, we're only keeping this. Okay. Well, those are all the questions we had. If you have any questions, please let me know in the comments. If you or your child wants help building a clear SAT plan to score above 1500, there is a link to book a free strategy session with our team below this video. Over the past year, we've helped over 30 students push their scores above 1500, and during that strategy session, we'll go over what that path would look like for your specific situation. So make sure to reserve your spot.